Hello and welcome back, dear students. We will tackle problem 2 and problem 3 of the duality theory tutorial. We start with problem 2. We have a case of two students that attempt to maximize the following linear program, which is a maximization problem with two resources and three variables. We are given the two final tableaus of the two students after doing simplex. So we're asked to provide and tell who is giving the right answer out of the two students without doing calculations. So the first thing we should look at is the problem. It's a maximization problem, however, it's not in the canonical form for the second constraint. As you know, for maximization problems, we often ideally have lower or equal signs in the constraint. So here the second constraint is not in the canonical form. We should keep that in mind for later. And looking at the two tableaus of the C-bar values, they're either 0 or negative, which means that we're dealing with the minimization problem, which is not the case. So we can deduce that students are trying to solve the dual and not the primal. Okay, so after keeping these details in mind, we would be able to tell who is giving the right answer and who did it the wrong way. So let's look at the answers. Here it says that when developing the optimal solution, dual solution, y2 will be equal to s2 and not minus s2, because the second constraint is not in the canonical form. So to invert the signs, we add a minus sign. So minus s2 would become s2. And that way we can now calculate the optimal values here. So the first student used the minus s2, so it inverted the sign here. However, the second student did not. So as I was saying, the first student inverted the sign of the slack variable s1 from -2 to 2. However, the second student did not, which made the calculations wrong and made him find a value of -18, which is wrong. So we can say here that at optimality, Z star equals to W star, which means that Ahmed is the student who is giving the right answer with Z value of 18. However, Fatma did not realize that the second constraint is not in the canonical form. She should have inverted the signs to be able to get the same optimal solution and the correct final answer. Okay, so now let's move on to the third problem. Here we have a maximization problem that's in the standard form. Already inserted the slack variables. We have three resources. So I was saying we have three resources with three variables and three slack variables. Maximization problem. So here we are asked to provide the primal and dual solutions. To provide the primal solutions, we look for the basic variables and bases. S1, which is equal to 23 over 3, x3 equals to 4, s3 equals to 7 over 3, and the rest of the variables, which are x2, x1, x2, and s, that's all, x1, x2 are equal to 0. Z is equal to 47 over 3. As for the dual solutions, they are equal to minus C bar. So we have y1 equals to 0, y2 equals to 2 over 3, y3 equals to 0, y4 e1 equals to 1, e2 equals to 0, sorry, e2 equals to 1, and e3 equals to 5 over 3. We can verify here in the solution. So as I was saying, here are the values of the optimal solution of the basic variables. All the rest of the variables receive 0. And for the dual, we have the minus of this column, the C bar column, with the same optimal value. So here we are asked to study the effect of one more unit of resource 1 on optimal profit. So to do that, we have to look at the slack variables of resource 1, which is S1. As you can see here, the slack variable of resource 1, S1 is not equal to 0, which means that we still have more resources of resource 1, so we should not be getting any more of units of resource 1 because that will have no effect on the optimal solution. It will only increase the slack variable. So third question, if only one resource can be supplemented by additional quantity, which one to select? So we're asked to study which variable, which resource to increase in order to get more profit. So for that, we look at the shadow prices of x1, x2, and x3. Shadow price of x1 equals to 0, which means that we should increase resource 1 by 0. X2 shadow price equals to 1, so means that we should increase up to $1, up 1 unit to get $1 profit. And x3 shadow price equals to 5/3, which gives us the maximum profit if we increase resource 3 by 1 unit. So if we can acquire additional units of one resource, it should be resource 3, since it has the largest shadow price. So getting 1 unit of x3 will give us $5/3 in reward. So would we purchase 1 additional unit of resource 2 at an additional cost of 2 units? It means $2 here. The shadow price of resource 2 is $1. So getting one additional unit of resource 2 at $2 is not logical, since we are only willing to pay $1 for resource 2. The shadow price of resource 2 is 1, hence we are willing to pay $1 per additional unit of resource 2, and we are not willing to pay $2 per unit for additional units of resource 2, so we will not be accepting this offer. And finally, if some available budgets allows us to increase resources, how to proceed? So as we said, we still have more units of resource 1. If we can acquire additional units, it should be resource 3, and the maximum we're willing to pay for resource 2 is $1. So if we have an additional budget, what resources will we increase? So primarily we will increase resource 3, since it has more reward, at the maximum price of $5/3, and resource 2 at a maximum price of $1 per unit. So if we have available funds, we will not acquire any additional units of resource 1, as we said, as the resource 1 is not depleted. And we will be willing to pay $1 per additional unit of resource 2 and 1.67 $5/3 per additional unit of resource 3. So here, this is a complete analysis of um, slack variables and shadow prices. Thank you for watching, and good luck.